All right, in this lesson, we're going to look at inverses of functions, and we're going to review them numerically, graphically, and analytically. So we're going to start graphically, but we're going to look just at a parabola function, and I'm going to show you what's going to happen here. So my normal parabola, at -2, it's up at 4. At -1, it's at 1. All right, so hopefully you remember this basic shape. There's my basic shape, right? Now what happens though, if I take the inverse of this function, and that's how we note it, the x and the y coordinates interchange. So -2 and 4 will switch. So x will be 4, y will be -2. X will be a +1, y will be -1. 0, 0, not much change there. 1, 1, not much change. And then 4 and 2 switch places. So this becomes like this. So I want you to look at what happened. My parabola turned, didn't it? The reason it turned is because an inverse means that it's a reflection across this diagonal of your graph. All right, this is the y equals x line. And so you can actually see how this is reflecting this way. It's just folding over this imaginary line. That is what an inverse does. Now, that is graphically what's happening. So a couple things I want you to just make note of, that they interchange coordinates. If f of x is xy, then f of -x has the coordinate yx, just like we saw right here, okay? What's happening graphically is there's symmetry with this line, the y equals x line. And then analytically, if you plug one function into the other, when you solve it, it comes out to be a +x. And then we're going to spend some time with the analytical here. Now, most of you remember good old vertical line test, right? Remember, vertical line test determines if it's a function. Well, now there's something to know about a horizontal line test, okay? The horizontal line test says this: if every horizontal line intersects the graph of a function at most once, then the inverse graph is also a function, all right? Passes the vertical line test. So if you look at our parabola, if we drew a horizontal line, look, it does not have a function, an inverse function, because look, its inverse we created here does not pass that vertical line test. So it no longer has an inverse function. It may have an inverse, but it's not a function. So we say it's a one-to-one function is a function that passes the horizontal line test, meaning its inverse is also going to be a function. Now, let's look at this. Find the inverse algebraically, all right? Then prove the algebraically that f and f -1 are inverses, okay? So I'll explain all this as we go, all right? So let's look at this. Find the inverse algebraically. Now, when you see it written like this, that x really is on the top. X over 5. All right, so the rule of thumb is when you want to find it algebraically, think of it like this. Think of it as y equals x over 5. And you're going to switch, I'm going to put that y over 1 so it's a proportion. I'm going to switch the location of x and y, just like we did the points earlier. We're going to switch it. So it's going to be x equals x over 1 equals y over 5. Now my job is to solve for y. Well, if it's a proportion, I can just cross multiply. So then y equals 5x. In an inverse notation, what we say is f of -1, that indicates the inverse of the original function is 5x. All right? Now, that's the first part. Find the inverses algebraically. Then prove that they are inverses. Now, notice what's happening here. I'm just making a composition. I'm putting the inverse function into the original, and when I solve it, it should come out to be x. So let's see what happens. If I take the original function, this is like a composition, right? F of my inverse should come out to be x. Let's see if that happens. So if I take the original function, so my original function says x over 5. Now I'm going to replace x with the inverse that we just found and see what happens. If I replace that, I have 5x over x, and if I solve it, it comes out to x. That's great, awesome, wonderful. But now we have to test to see if it works the other way as well. If I take the inverse function and I plug in the original in there, does it come out to be x? We need it to come out to be x to prove that they are indeed inverses. So let's see what happens. So if I take the inverse function, so I'm going to take 5, and I'm going to plug in the original, which was x over 5. When I solve that, I'm back to 5x over 5, which is just x. So because they both turned out to be a positive x when I plugged them into each other, that is my proof algebraically that they are inverses. Now, let's try the next ones. Show algebraically that f and g are inverses. So they're just naming them f and g instead of f and f negative 1. So I'm just going to do compositions. I'm going to do f of g of x. Let's see what happens. So I'm going to take the f structure, x cubed, and I'm going to plug g into it. So it's the cube root of x cubed. Well, what do you get when you cube a cube root? Well, we get x, so that worked. Then if I flip it, g of f, I'm going to take the g function, the cube root, but instead of x in there, I'm going to put the f equation, x cubed. Again, if I take the cube root of x cubed, I get x. All right, so that proved it. Wonderful. Now look at this one. F of g of x. All right, so take the f function, square root, instead of x, I'm going to put x squared plus 4 minus 4. These cancel out, right? So I'll have the square root of x squared, and that gives me x. That works. Then if I take g of f of x, it says something squared plus 4, right? Well, I'm going to do the square root of x minus 4, because that's what the f function was. If I square root, the guts fall out. Plus 4 gives me x. So this is my proof that they are inverses. Now, in the next portion of your notes, it says if a function is 1 to 1, remember it passes the vertical line test, then we can find its inverse. So a lot of this information right here for a and b, all this, I really don't want you to worry about it. This is not something you need to worry about. So when the instructions say determine algebraically whether the inverse function is 1 to 1, what I'm really asking you to do in this lesson is to verify graphically that it passes the horizontal line test. If it does, then you're going to find the inverse. All right, so you're going to use your calculator here. Now, in my calculator, if I graph this, I know that this becomes a square root function, and it looks like this. So it's going to pass my horizontal line test. All right, so all is well, all is good. I can continue on now finding my inverse. So remember what we said, we're going to replace that f of x with a y equals the square root of x plus 1. Then I switch the x and the y. And my job now is to solve for y. So I'm going to subtract 1. I'm just going to put the square root of y over here. It'll be x minus 1. Then it says to square both sides. So y equals, this is now going to be negative f of negative 1 of x. So x minus 1 squared means I got a FOIL. So I'll have x squared minus 2x plus 1. So this is my inverse function. All right? Number 5, it says, let's look at this. If we graph this, I'll just tell you this. It's not going to pass my vertical line test. If I graph this, it is going to look like this. So when I graph it, it actually looks like a parabola. Now I think about the horizontal line test. Does this one pass the horizontal line test? No. It crosses twice. So that means there's no inverse function. So that's where I'm going to stop, and that's my reasoning. It's not 1 to 1. So we would say not 1 to 1, which means it does not have an inverse function. Now, number 6, when I graph this guy, this is really just going to be a straight line, and it looks like this. Example 6 is going to just look something like this on my calculator. Now I think about my horizontal line test. It will pass. That means I can go through the motions and then find the inverse function. So I'm going to replace this with y and then switch my x and y. So x will equal 3y plus 4 over 5. Put that x over 1, and then I'm just going to cross multiply. So I'll have 5x equals 3y plus 4. Solving for y, I'm then going to subtract 4. I'm going to put my 3y on the left just because I like it better there. So 5x minus 4 divided by 3 over here. So then my inverse function will look like this. It'd be 5x minus 4 over 3. And that's my inverse function. All right? Now the rest of this, I want you to try it on your own. We are going to start here in class and see how you're doing with finding the inverse algebraically of this function. I covered it up right there. And then it says to prove it. So let's see if you remember how to prove it. And number 2 is what we just did up here. Graph it. If it's 1 to 1, find its inverse. All right, good luck. We'll see you in class.